For the given polynomial fx equals negative x to the fourth plus 6x cubed minus 9x squared, answer the following. Describe the end behavior of f. So this is fourth degree polynomial 4, and negative 1 is the leading coefficient. So negative fourth degree. Fourth degree, that's even and negative. That means our graph looks like something like, I don't know, like this. Okay, fourth degree, so it's even up or down, that would be the case, even degree. But negative, so it will be this. Okay, falls to the left and falls to the right. So part A, the end behavior falls to the left and falls to the right. In part B, find the real zeros of f. So we need to find the roots or zeros of f. So we solve the equation fx equals 0, that is negative x to the fourth plus 6x cubed minus 9x squared equals 0. So negative at the very beginning, so we can pull negative out. X fourth, x cubed, x squared. Out of all three terms, we can pull x squared out. Negative out, x fourth, x squared. So x squared remains. Negative, positive, negative. 6 x cubed out of 3, 2 are out, so 1. Negative, negative, positive, x squared out, 9. Okay, we'll factor this further. So negative x squared, let's factor this trinomial, x squared x, 9, 3 times 3, 9, to get negative, negative, negative. So negative x squared, x minus 3, x minus 3, x minus 3 quantity squared equals 0. So the roots are, so real zeros, the roots are, or zeros are x squared. Okay, x squared, just the x times x, and the whole thing becomes 0 when x equals 0. So 0 is a 0 or root of this polynomial, and x minus 3 becomes 0 when x equals 3. So 3 is also a 0 or root of the polynomial. Okay, 0 and 3. Part C, state whether the graph crosses or touches but does not cross the x-axis at each 0. So we have 0 and state the multiplicity. Okay, 2 square is square, so the multiplicity 2. So we should have made a table. So multiplicity of this root is 2 because x is squared. Same thing here, multiplicity is 2 because x minus 3 is squared. That means even multiplicity. So when we have even multiplicity, what happens when the graph comes? It just touches but does not cross the x-axis. Or if the graph comes from below, it just touches but does not cross. So at both zeros we get the same property. So at both zeros, the graph touches but does not cross the x-axis. Okay, that's C. Now find the intervals over which the graph of f is above or below the x-axis, and what is the maximum possible number of turning points. So we can answer this easily. Maximum possible number of turning points for this polynomial. So let me answer over here. What is the degree of this polynomial? Degree is 4. That's the highest exponent. That means 4 minus 1, 3. So the number of turning points 3. Okay, because the degree is 4, we can have at most 3 turning points. Now we need to answer D. Find the intervals over which the graph of f is above or below the x-axis. So we can sketch a rough graph for this one. Okay, so for D, this is the x-axis, y-axis. We have two zeros, by the way. 0 is a 0 and 3 is a 0, and we know the graph eventually falls, so it goes here, falls, and it falls here as well. Okay, and multiplicity 2 means when we start, let's start from the left, it just goes to the 0, touches but does not cross. And again for 3, it just goes to the 3, touches but does not cross the x-axis and falls like this. So it's going up, touches, again touches, and eventually it has to fall on both sides. So this is negative infinity to positive infinity. So the graph is never above the x-axis. Okay, find the intervals over which the graph of f is above or below the x-axis. The graph is never above the x-axis. The graph is always below the x-axis. The graph is below the, let me always, it wants us to write down intervals. So the graph is below the x-axis on all the way negative infinity through positive infinity. That means the graph is never above the x-axis.